All right, so let's go ahead and do this. I'm going to be giving you 6 examples of chapter 7.5, which is factoring trinomials. But before I do that, what I would like to do is I would actually like to take you back to 5th grade for a second, just to make sure that you guys remember the vocabulary, okay? So this is just a little vocab thing. You don't need to write this down if you don't want to, but you can. Just a little bit of vocabulary. So back in the 5th grade, you learned to multiply, and your teacher gave you this little vocab. She taught you that 2 times 3 equals 6, and she told you that that 6 was called a product. And then she told you something that you forgot. What are the 2 and 3 called? Does anyone here remember what the 2 and the 3 are actually called? The answer is called a product, but what are the 2 numbers that you're multiplying together called? That is the question I have for you. Indeed, Caden, that's what they're called. Those are called factors. So in this particular chapter, 7.5, what it's asking you to do is it's asking you to factor a number or factor an expression. So this is what you learned in grade 3. You learned to multiply 2 times 3. They taught you multiplication. Then what they did in grade about 6 is they taught you how to factor. So in grade 6, your teacher would then say, all right, here's what I want you to do. I want you to factor 15. In other words, I want you to find the 2 numbers or 3 numbers or whatever numbers that multiplied together give you 15. And that, of course, was 5 times 3. So that's called factoring. And that is what we're going to be doing today. Except that we are going to be doing it not with 15 or easy numbers. We're going to do it with trinomials. All right? So we're going to do 6 examples together. And these are examples of factoring. Factoring is an algebra skill that is going to stay with you throughout your high school career. You're going to be factoring every single year that you're taking algebra. So here's the first example. We are going to factor x squared plus 9x plus 20. And what I mean by that is the same thing your 5th or your 6th grade teacher meant. I want you to figure out what times what gives me x squared plus 9x plus 20. So this is the exact opposite of what we did on the warm-up. On the warm-up, I said multiply these 2 things, give me an answer. Now I'm giving you an answer, and I want you to tell me what 2 things are multiplied together. So I'm going to pause right there just for a second and think, is there anyone here or anyone over there that can figure out what times what would give you x squared plus 9x plus 20? And I'll give you a hint. It's x plus something times x plus something. What would it be? Any guesses? You can use the very famous question mark. Too complicated, Mr. Hintz, but a good guess. Oh, we are stuck. We are stuck. It's the warm-up backwards. I'm giving you the answer, and I want to know from you, what is the question? I will wait another 15 seconds to see if there's any genius this morning. It's like Jeopardy. I can play the music. And so on. No, you didn't spell it right, but that's okay. Okay, obviously I'm not getting any responses, so you guys are like, I don't know, Mr. Brady, that's why we're here. Teach us. So that's what I will do. I will tell you that one of the factors is going to be x plus 4. All right, I've given you another hint. So it's going to be x plus 4 times x plus something. What's the other number that's missing? There you go. We're missing the 5. All right. This, ladies and gentlemen, is called the factored form. We have taken a trinomial. My original question, the x squared plus 9x plus 20 is a trinomial, and I factored it into the product of two binomials. So this actually factors into x plus 5 times x plus 4, in the same way that 15 factors into 3 times 5. And what I'm going to do now is, you don't need to write this down, but I'm going to check it. So I'm going to just make sure that I did this right. So to make sure I did it right, what I'm going to do is I'm going to multiply. So x times x is x squared. X times 5 is 5x. 4 times x is 4x. And 4 times 5 is 20. Combining those middle terms, I get x squared plus 9x plus 20. See? It works. So that is my factored form. All right. Let's try another one now that you kind of know what we're aiming for. And let's see if you can figure it out a little bit better. We have 6 examples this morning, so you've got time to catch on. All right. Second one is x squared plus 7x plus 12. What would that look like in factored form? Let's see if anyone can get it this time. Okay, we have a first guess. Oh, we have a second guess. Oh, we have a third guess. Hey, they're all the same. Actually, you'll notice that the first two say x plus 4 times x plus 3, and the last one says x plus 3 times x plus 4. Those are the same thing. They're all correct. So it doesn't matter which way you do it. It's either x plus 3 times x plus 4 or x plus 4 times x plus 3. Now, I'm going to check it one more time just to make sure you guys see where we're getting this. So x times x is x squared. X times 4 is 4x. 3 times x is 3x. And then 3 times 4 is 12. Combining those two middle terms, we get x squared plus 7x plus 12. Okay, we're doing a lot better now. I had 4 people with the correct answer there. Now, there are 20 people in class right now, and 4 of you said, all right, I got it. So the other 16 people might be wondering, well, how in the world did they get that? So does anyone have a quick trick for how you could get this? See? People are like, how did you get it? So please, either turn on your mic or type it in there. How did you get it? I mean, you must have done something to get it. What? What did you do? Oh, well, you didn't do this in 5th grade. All right. Let's see. So Xander's saying that 4 times 3 is 12. So you're looking for factors that go into this number. So notice that over here in this first example, we had 20, and 4 times 5 is 20. So that's how we got that. And in the second example, we had 12, and 3 times 4 is 12. But Shane is adding something else, and so is All Enjoy. She's saying, but at the same time, they have to add up to 7. So here is what you're looking for. You're looking for two numbers that multiply to 12, true, but they have to add up to 7. I'm going to write that down. We are looking for two numbers that add up to 7, and at the same time, and multiply to 12. And these people are saying, well, if I'm looking for two numbers that add up to 7 and multiply out to 12, that would be 3 and 4. Because 3 plus 4 is 7, and 3 times 4 is 12. You see it now? That is what they're doing. Now, the title of this lesson was factoring x squared plus bx plus c. So in general, we call this letter, the 7, the b, and this 12, the c. So it needs to add up to whatever this number is, b, and has to multiply out to whatever this number is, c. So that's our general pattern. So let's see if you get it now. So what I'm going to do now is I'm going to change this one number. I'm going to make this x squared plus 8x plus 12. So what would it factor to now? If instead of being 7x, it was 8x. Now what would it factor to? So for those of you who might be stuck, I'm going to go over here. I'm going to put a little bubble. You're looking for two numbers that add up to 8, the middle term. And at the same time, these two numbers need to multiply out to 12, which is your last term. Multiply out to 12 and add up to 8. So what would your answer be? There you go. That's right, Porter. So he's like, well, those numbers are going to be 6 and 2. Because 6 plus 2 is 8. On the other hand, 6 times 2 is 12. And therefore, when I factor it, all I need to do is I write x plus 2 times x plus 6. That's it. And now you're going to get it. How you feeling about that, Leah? One thing that I've been doing so far in these first 3 examples is I've only been using positive numbers. What if I decide to get a little bit meaner? Oh, good. I'm glad it makes sense. And I were to add some negative numbers to the mix. So that's what we're going to do now. Oh, yeah, I'm sorry, Ms. Diaz. We are going to add some negative numbers. So here we go. Oops. We're only doing 6 examples. We're halfway. X squared minus 2x minus 35. Okay, so we're going to use our trick. We're going to look for two numbers that add up to negative 2. So their sum is negative 2. And we're going to find two numbers whose product is negative 35. So can you think of numbers that do that? And if you can think of numbers that do that, then you can factor this. And in your assignment today, all the numbers there's small integers, no weird fractions or anything. Very doable numbers. Don't look in the chat. Think. All right, you can look in the chat. Well, we only have one vote there. Caden, I think you only have half an answer. You're missing it. Oh, there. Thank you, sir. There's the other half. So, okay. Good. So the two numbers that do that are going to be 5 and negative 7. So 5 plus negative 7 is negative 2. On the other hand, 5 times negative 7 is going to be negative 35. And therefore, x plus 5 times x minus 7 is going to be the factored form. That's what you're going to do. Or backwards, you could also do, here, I'll write that, just to make sure it's clear for everyone. Or x minus 7 times x plus 5. And that is what your assignment is about. It's going to ask you to factor this, or it's going to say write the factors of. And you got to come up with these two factors. Let's go to number 5. All right. This time I'm going to do this. I'm going to have minus 3x. No, wait, hang on. No, I don't want minus 3x. My bad, sorry. Brain fart. is simply minus 11x plus 30. Sorry about that. I lost track of what I was doing. Okay. So think about that one. I'm going to give you no hints. Okay, hint. It's kind of weird, but we're looking for two numbers that add up to negative 11 and at the same time multiply out to positive 30. So think about it. If they need to multiply out to negative 11, you add up to negative 11, but multiply out to positive 30, that means that they both need to be negative. Because a negative times a negative gives you positive. Exactly, guys. Y'all in the chat, you're there. In other words, negative 5 times negative 6 is positive 30. And at the same time, negative 5 plus negative 6 is negative 11. And therefore, that's going to be our factored form. We're going to have x minus 6 and x minus 5, or the other way around. Good. All right, one last example. And this is the only other thing that could go wrong. So we could have two negatives. We could have one negative in the middle, or we could have one negative at the end. So here's the last possibility. What if we had the negative over there? So we're going to factor, for our last example, x squared plus x minus 42. So we're looking for two numbers that add up to, there's nothing there. So don't forget, when there's nothing there, that means there's a 1 there. So we're looking for two numbers that add up to 1 and at the same time multiply out to negative 42. How could two numbers multiply to negative 42 but only add up to 1? I guess that's the question. There you go. If you look in the chat, someone that's more or less your age figured it out, which means it's possible. So here we go. 7 and negative 6. If I add 7 and negative 6, they add up to 1. On the other hand, if I multiply 7 and negative 6, they multiply out to negative 42. And therefore, my answer must be x plus 7 times x minus 6. And there you go. That is lesson 7.5. That's all I've got to say. So what I would like for you to do now is I would like for you to go to Big Ideas and work on this assignment. There are 15 questions, and they're all like this. That's all it is. So if you have no questions, you can take off. Go ahead. Go do it. Thanks for coming by. Thanks for helping me, guys, especially those of you in the chat. And if you have any questions, please stick around and ask. I'd be glad to answer them. Okay. See you later. Bye. It's Friday the 13th. It's Tuesday the 13th, but okay. All right. Stop this video. How do I stop the video?